We're going to look at something called an Atwood machine. An Atwood machine, first of all, it says video, a baffling balloon behavior. I showed you that one already, actually. That was where we said a balloon, a helium-filled balloon inside a car will act like an accelerometer in that it will actually point in the direction that you're accelerating. And the reason was we needed to realize that the air was actually sloshing around. We had to talk about why it is that a helium balloon floats. It doesn't float. It moves to the area of the least amount of density. And since the air, when you hit the gas, the air sloshes to the back of the car, it's slightly less dense in the front of the car, and the helium balloon will try and move to the front. It will point in the direction of the acceleration. So we talked about that. Jimmy, the Atwood machine is a pulley system as seen below. Hey, everybody look up. This is an Atwood machine right here. When one mass goes up, the other mass goes down. They'll accelerate at the same rate. Again, we're not going to allow you to do that. But now I have to get a little stupid. This is not an Atwood machine. In our Atwood machine, the ropes have no mass because that would make the math yucky. So it's not a real life actual situation. Oh, in our Atwood machine, this pulley has no friction and no mass because that would also make the math yucky. So an Atwood machine is more of a theoretical construct, McKenna, but it's going to allow us to look at some nice physics concepts as well. So it's on a pulley system. Typically, the second mass is called a counterweight. And when one goes up, the other mass goes down. Typically, we call them mass 1 and mass 2, or mass 2 and mass 1, so M2, M1. Here's our thought problem. We're going to vote, because we haven't voted for a while. It says this: suppose equal masses are placed on both sides of the Atwood machine, and one mass is lifted higher, like this picture right here. When we let go of the masses, what happens? A, the system remains at rest. B, the higher mass falls down because of gravity. Or C, the higher mass goes higher because the other one's closer to the Earth. So if you look up, we're talking about this here. And again, no friction. Imagine no friction in this pulley right here. And we've lifted the one on the right up higher. So if there was no friction here, because these masses are identical, and I let go of this, what's going to happen? A, the higher mass is going to fall. Sorry, A, nothing's going to happen. B, the higher mass is going to fall. Or C, the higher mass is going to go higher. Got the question? Ponder for a second. Once again, we're going to vote. Once again, how high you hold your hand up is how sure you are of the answer. I'm positive. Pretty sure. Only voting because Mr. Duke will make fun of me if I don't vote, and Mr. Duke will make fun of you if you don't vote. Okay? Who says, A, Mr. Duke, nothing's going to happen? A, nothing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Interesting. Who says B, the higher mass is going to fall because stuff falls down? 1? Was that a very subtle yes vote so no one would notice? The old water bottle disguise? 1? Just 1. Huh. Who says, no, the higher mass is going to go higher? Okay, 1, 2, 3, 4, 5. Huh. I'm not going to answer this question. We're going to figure it out ourselves. How? Anybody want to guess what this might be a good job for? We're going to do a free body diagram, and I'll do it on the right-hand one, and I'm going to zoom way in just so you can kind of see what's going on here. So if I zoom in on the right-hand picture here, let's start on the left. What are the forces acting on this mass? Get the obvious one. Yep. Is that okay? What else? And I think I said last day, and I'll repeat myself, you're going to start to notice now when we're getting the free body diagrams, Chase, I'm going to give you fewer and fewer hints. All the stupid little repetition that I did before, because I can't do that for you on the test. I'm going to slowly wean you away from that and have you maybe do that in your head, which is why I keep repeating myself, which is why I keep repeating myself, which is why I keep... Oh, shut up, Mr. Duke. What else? Tension. Yeah. Anything else on that left-hand mass? Okay, what are the forces on the right-hand mass? Get the obvious one. Now, normally I would say, is there more than one mass? I'll label them as M1 and M2, but did it say that they were identical masses? So I'm going to use the letter M, Jimmy, for both of them. What else? Good. So we had 12 people pick A, 1 person pick B, 5 people picked C. Let's pretend that C is correct, just out of curiosity. If C is correct, if the higher mass goes higher, you're saying everything is accelerating in that direction. Is that all right? Which means I think you're saying that this mg, the right-hand mg, is winning. So let's do our winner minus loser equation, and anything that ends up pointing down once it gets to the right-hand side, we'll call winner plus. Anything that ends up pointing up once it gets to the right-hand side, we'll call loser minus. And let's see if we can write an equation here. So I would have mg, and then this tension here would be loser minus. Now, this tension here is pointing up, and you might be tempted, Chase, to say it's a loser because the other one was pointing up. But Hayden, if you follow it, I think when it gets to that side, if you kind of imagine the arrow slowly moving along, I think it ends up pointing down on the right. Is that okay? So I think that tension is going to be a winner plus. Now, this mg here, you might think is a winner because it's pointing down, but if you follow it all the way to this side, I think when it gets to the right-hand side, Nicole, it ends up pointing up. Sorry, up. And so I think that makes it a loser minus. Do I have forces from more than one mass on the left? Then I better have forces from more than one mass on the right. So this is going to be M all A. Put your pencils down, stretch it out. Why am I so relaxed? Why am I stretching? Excellent. Oh no, why am I stressed again? Why do I have tension again? What else is happening that's weird? No more MGs. Oh. When everything cancels, be obvious what number must be left behind, because we can't just leave it blank. What number as a value must be sitting there when everything cancels? 0. I get this. 0 equals now remember, on the right-hand side, Hayden, this is something times something, mass times acceleration. If you're multiplying and you get 0 as an answer, one of these must be 0. In other words, if I say A times B is 0, either A was 0 or B was 0. That's how the 0 times table works. Is the mass 0 of these objects? So Chase, what must be 0 then? I'm going to go really high tech. I'm even going to put a therefore. A equals 0. So if there's no acceleration, which of those 3 answers must be correct? A, B, or C? What's the only one that has no acceleration? A. Yeah. So I'm even going to do another therefore. Answer A. That's an example of a Physics 12 proof that I would totally accept. It says, using principles of physics, explain your answer. We absolutely did that right there. And what I like about this, Jimmy, do you notice no English, no numbers? We did a purely algebraic proof, but we ended up with a nice conclusion. I will not expect you to pull off one of those in Great Physics 11. I kind of will expect you by the midpoint of Physics 12 to be able to pull something like that off. For those of you that have signed up. Now, this is actually really handy. How many of you have been in an elevator before? Okay. There's 2 types of elevators. If you're in a small building, like a 2 or a 3-story building, like the one, for example, the elevator in our school, that's a piston-driven elevator. There's just a big pole underneath that makes the elevator go up and down. But anything higher than about 3 or 4 stories is a cable-driven elevator, and in fact, it's an Atwood machine. You don't notice, but somewhere else there's a counterweight that's the same mass as an empty car. And so that means the motor only has to lift the people, not the actual car itself. It's way more efficient. It also means that once the elevator car is empty, when people get off, the motor doesn't have to expend any energy to keep it at that floor. It can shut off and things are in balance because it's not going to accelerate. Very clever. I like example 2. There's going to be an Atwood machine on your test. Tell you that right now. A says write force equations. Okay. B says find the acceleration, and C says find the tension. And Julie, I hope you're noticing, that's kind of familiar, like lesson 7, it was always find the acceleration, find the tension. Is there more than one mass in this equation? I'll bet you we'll find the acceleration by writing an equation. You know what? We'll find the acceleration of everything by writing an equation for everything, but then to find individual forces, we'll look at individual masses. Sound familiar? Okay. How am I going to start? Well, it says write force equations. Yeah, what would I probably do even before that? I think I'm going to do a free body diagram. So they got M2 on the left. Okay, what are the forces acting on M2? McKenna, get the obvious one. Yep. What else? What about M1? Who's winning? The Atwood machine is fairly easy. Sky, typically the heavier mass is going to be the winner. I'm hoping that's fairly Captain Obvious, that you've learned enough physics now that you kind of, yeah, heavier one's going to go down. Which is the heavier mass, the 1.2 or the 3.8? Be obvious, McKenna, which is the heavier mass, M1 or M2? Now, I realize M2 looks smaller. That's because I just stole this picture from the internet. Just pretend M2 is denser. Maybe this is like lead and this is like wood or something. Anyways, M2 is heavier. So who's winning? M2 is not a force. Which force from my free body diagram is winning? I'm being fussy now. M2G is the force. So McKenna is correct. Anything that ends up on pointing down, once it gets to the left-hand side, is going to be a winner plus. Anything that ends up pointing up, once it gets to the left-hand side, is going to be loser minus. So McKenna, for part A, it says write a force equation. Talk to me, kiddo. I'll give you a hint. Winner. Yep. Yeah. This smaller mass is acting like a brake, slowing down the acceleration. But this bigger mass has enough mass that we are accelerating. Built-in error check. First of all, pencil, relax, losing tension. Oh, ha, 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 ha. What are we trying to find, McKenna, in part B? Built-in error checks. The biggest this can be if I cut the rope is... Oh, I have a guest coming here. Hang on, let me pause the video. No, wrong button. So built-in error checks. The biggest A can be is 9.8. Other things. If both masses are really close to each other, there's barely going to be any acceleration. First of all, if the masses are identical, A is 0. We just proved that. If they're really close to each other, there's barely an acceleration. It'll probably be like less than 1, probably. If there's a huge difference, it'll be closer to 9.8. So if this was 380 kilograms and 1.2 kilograms, I'd be expecting an answer above 9. You don't need to know any of that, Jimmy. You can survive just fine without it. You gonna make it, Jimmy? Okay, because you looked like you were away from us. Jimmy, what's B asking us to find?
The acceleration.
How would I get the A by itself? How will I move the M all over? What's the M all doing to the A? Adding. So, yep. Are we? I've mentioned a few times, but I'll repeat myself. See how I did that? You may notice we're doing the same mathy steps over and over. It's either swappy dance, it's divide to get something by itself, or it's plus something to the other side, or minus something to the other side to get something by itself. So I think you're saying, Jimmy, this. A is going to be divide by M all, M2G minus M1G. In your homework, if you want to go straight to your calculator on this step, I'm okay. In our notes, let's plug in the numbers so that when you're studying later on, you know what the heck we did. M2 was 3.8 times 9.8 minus 1.2 times 9.8, all divided by 1.2 plus 3.8. One common sloppy mistake that I see kids make is M all, you're going to add the masses together. I do see some kids put a times there for some reason. Every one of you needs to practice typing this in. This is the level of difficulty on your calculator that I expect you to be able to handle in your sleep, to be frank. I have no idea what the answer is. Well, I know it's less than 9.8. M2 is about 3 times bigger. Are you getting something in the 5 range? Okay. I got a few tricks up my sleeve where I can make some pretty educated guesses just because I've done a bunch of these. What'd you get? 5.0. So 5.10 if I go to 3 sig figs, is that right? But keep that number on your calculator. Did you get that okay, Alec? Okay, good. 5.10 meters per second squared. I usually put a box around it because, yay. Cool. Sean, what's C want me to find? An individual force will find an individual mass. It doesn't really matter which mass I pick. Both of these look equally easy. There's not one that's really yucky with a whole bunch of forces on it that I would avoid. Although if I was really lazy, I'd pick the one where tension was the winner because it's easier to get the T by itself. In which one is tension the winner? I would go tension minus M1G equals M1A because M1 is accelerating up. Do you see why I did that, Hayden? Because how would I get the T by itself, folks? Just plus the M1G over. You could have gone like this. M2G minus tension equals M2A. That equation will work too. And swappy dance. They're equally, I mean, you're going to write one more line no matter what. So this is really pick 'em. I really don't care which one you go with. Oh, you know what? How about this? This half of the class, you're going to solve this equation for tension. This half of the class, you're going to solve this equation for tension, swappy dance. And let's see, using your answer button, if we get exactly the same answers. So the left-hand side of the class, you'll go tension equals M1A plus M1G. The right-hand side of the class, swappy dance, which would be do that. You'll get tension equals M2G minus M2A. Make sure wherever there's an A, you use your answer button, assuming your answer was correct. What'd you get, Sky? That's my way of saying pick up your calculator and type. Thank you, Chase, because I was on you next. Sam, what'd you get?
17.5.
Can you read me a bunch of digits? 17 point... And I think you guys also have 17.875. And again, the point is, doesn't matter which mass you pick, Hayden, pick the one that makes your life the easiest. In this case, they're both about equal easy. So 17 point what? 9? Turn the page. You're going to get this same question on your test, but with different numbers. Oh, but I may have the left-hand mass be the heaviest one, or I may have the right-hand mass be the heaviest one. I don't know. Or, you know what? I probably have several different versions of the test, Emma, where it depends on when you're... Okay. So, it says Emma, what does it want me to find? And then I'm going to freeze my screen. Try this one on your own. If you get stuck, I'll unfreeze the screen every so often and you can look up. But see if you can just solve this on your own. So we're just trying example 3 on our own full solo. No idea what the answer is. Is that right, Mr. Dewick? Any typos? Copied everything down right. Looks good. Let's even do this, Mr. Dewick. I got that for the acceleration. Think. People nodding. Tension. You know what? I'm gonna go. .5, I think. I think you should get that whichever mass you use. The other one would be 5.7 times 9.8 minus 5.7 times 2.34 using your answer button. You should get the same thing, I hope. Okay. Believe it or not, that's a Physics 12 provincial exam question. It's worth 7 marks, and I'll probably make it worth like 5 marks or even 7 marks on your test so I can give out lots of part marks. So don't skip steps. Which one you wondering about? You good? Okay. Put your pencils down, look up. Continue. Ooh. Emma, what's example 5 asking me to find? Yes, this is a missing mass question. I like this question. I like this question. I like this question. And Hayden, this is the first missing mass question that I've given you. It's going to be exactly the opposite of what we've been doing so far. In the previous question, I gave you both masses. You used that to find the acceleration, then you looked at an individual mass to find an individual force. Here, I've given you one mass. I either have to give you the tension or the acceleration. I will give you one of those. We're going to use that to find the other acceleration or tension. Then we're going to look at the missing mass. We're still going to start out Campbell the same way. This is a good job for us. Campbell, what are the forces acting on M1? Get the obvious one. Yep. What else? What are the forces acting on M2? Get the obvious one. Don't write this next bit down. If I did an equation for everything now, the problem would be in that equation, I would have two things that I don't know. So instead, we're going to reverse this. Since we're trying to find a missing mass, we're going to start with the mass that we do know. Lillian, which mass do I know? Mass number. And which way is mass number 1 accelerating? I have to tell you that. Otherwise, this is not solvable. Which way is mass number 1 accelerating? You know what? Let's draw a little arrow there and let's put an A for acceleration. Lillian, give me an equation just for mass 1. So ignore mass 2 because I don't know how big it is anyways. Don't scribble it out like that. I just did, but pretend it's not there. Who's winning on mass 1? Who's losing? And that would equal M1A. Lillian, did they give me the tension in this question? Then I can find A. Or, Sky, I might give you A, but then you could find the tension. No matter what, as long as I give you one of them, you can find the other one by looking at an individual mass. Lillian, I want to find A. How would I get the A by itself? A ends up being tension minus M1G divided by M1. Lillian, how big was the tension exactly as a number? Minus M1, 3.2, G, 9.8, divided by 3.2. Everyone gets their calculators out. What's the acceleration here? And I'll do that on mine as well because I'm going to want this. 56.5 minus 3.2 times 9.8, close bracket, divided by 3.2. You get 7.85625. I'm going to be using this, so either I'm going to use my answer button or I would write all this out. I would try and avoid rounding off. So I'm going to write 7.8. You know what? 7.85625, that's not too much to write. 7.85625. Because that's not what I'm trying to find. Jordana, what was this asking me to find? Mass 2. Now, Jordana, we're going to write an equation for mass 2. Which way is mass 1 accelerating? So which way is mass 2 accelerating? Who's winning? More specific, that's not a force. Which force from my free body diagram is winning? Can you exactly read the three things that I wrote right there? Okay, which force is losing? So now I'm going to write an equation for mass 2, and it's going to look like this. M2G minus tension equals M2A. See how we hopscotched to the mystery map? But first of all, we had to find, we need both tension and acceleration to find mass 2. If you give me one and the other mass, I can figure out what's missing. Jordana, do I know G? 9.8. Do I know tension? Do I know A? Then I can find M2, but what's the problem here? How many M2s do I have? How many would I prefer? Let's get them to the same side, at least. I'm going to do a swappy dance, if you don't mind. And I'm going to have this. M2G minus M2A equals tension. You okay with that, Sky? How many M2s do I have, Sky? How many would I prefer? You know, it'd be really cool. It would be really neat if there was a Math 9 operation that I could pull out of my back pocket and somehow change this from 2 M2s into 1 M2. And there is. Yeah. Not exponents. I'm going to pause and see if anybody can have that aha moment. Anybody know what I can do? Chase, is there an M2 in everything on the left-hand side? Well, then I can factor it out. It's going to look like this. M2 bracket G minus A. Quickly multiply that out in your head. Did I do it correctly? Do I get the previous line? I did. Hey, Jordana, how many M2s do I have now? Really? I need to move the bracket over, Jordana. What's the bracket doing to the M2? So how do I move the bracket over? Isn't that nice? M2 is going to be tension divided by G minus A. Now, right around now, some kids are tempted to say, oh, I'll just memorize this equation, or I'll add it to my green sheet. You know what? If M2 is a winner or if M2 is a loser, the equation is going to change. If I can muck it around. I wouldn't try and memorize this, Justin. I've taught you how to derive it. Lillian, let's finish this, you and I. What was tension as a number exactly? G 9.8 minus A. All right, 7.86, but I'm going to use my answer button to get the 7.85. Is this a fraction? Yeah. Is there more than one thing on the bottom? Definitely brackets around the bottom. I get 29.1 kilograms. Now, I knew because M2 was accelerating down that it's going to be bigger than M1, so there's a bit of a built-in error check there. I knew that. 29.1 kilograms. That, my angels, is how we find a missing mass. We reverse what we just did with the Atwood machine. Instead of looking at everything and finding the acceleration of everything, look at the mass that you do know, and you can either find the acceleration or the tension. I'll give you the other one. Then look at the mass that you don't know. You'll almost always find there's two of them. Get them to the same side. Math 9 GCF to change it into one of them. And then easy peasy. I'm going to, on Friday, when I see you next, pick up with example 6, which is another question where we're finding a missing mass. But I'm done the unit. We've done it. So I'm going to give you a bunch of homework, although it's not due next class. Friday, I'm going to do this, and then Friday is going to be Ask Me Anything. Then when I see you on the following Monday, I'll be giving you your final take-home quiz for this unit. I'll give you the study guide as well. Wednesday next week, we'll mark the take-home quiz. And I'm thinking we can have your test on this Monday or Wednesday the following week. We'll talk about that. Okay? For now, you are capable of doing number 1. You are capable of doing number 2. You are capable of doing number 3. Number 4 is finding a missing mass. Number 5 is finding a missing mass. Let's see. 6 is finding a missing mass, and that's the same dealio. No, I'm going to skip 6. 7 is good. You know what? I'm actually going to skip... Ooh, Mr. Dewick. I'm going to skip 4 and 5. Now that I think about it, I realized in those I'm finding both masses, but 7 is good. 8 is good. 9 is good. Put your pencils down, look up.